Alright, so today we're going to do this problem regarding measure theory. So, prove that if f sub n converges to f pointwise almost everywhere on E, then f sub n converges to f in measure. So that means for every eta greater than 0, limit as n goes to infinity of the measure where it doesn't converge in measure is equal to 0. Alright, so now let's first fix eta. Let us define a sub n as a set that we want. So all x in E such that sub n x minus f sub x of x is greater than eta. Okay, so we want this to be a descending sequence of sets because the intuition is basically that if we have a descending sequence of sets, then that will kind of get smaller and smaller and smaller, so we can show that the measure of that is equal to 0. But this actually will not be a descending sequence of sets because we only know f sub n converges to f pointwise almost everywhere. So this means that our f sub n could jump in and out of eta. So what we instead want to do is we want to define g sub k is equal to the union from k equals n to, n equals k to infinity of a sub n. And now we have g sub 1 is a superset of g sub 2, superset g sub 3, ... because we're unioning over less and less things, which means that we have more and so we have a smaller and smaller and smaller sets. Okay, so now since we have this descending sequence of sets, we can say that due to by the continuity of measure, the measure of the intersection, all the g sub k's, infinity is equal to the limit as k goes to infinity of the measure g sub k. Okay, so now we can see, because we're basically pulling this limit out, okay, so now we can see that since, so letting C equal the set of all x in E, such that f sub n is not converging to f pointwise, you can see that g sub k is a subset of C. Because C is the set where it doesn't converge pointwise, aka for all epsilon greater than 0, f sub n x minus f of x is greater than epsilon. And then our g sub k is basically a subset of all the f sub n's for which that is going to be true for an epsilon. Okay, so now that we know that this is true, we know that the measure of g sub k is less than or equal to the measure of C, and we know that's equal to 0 by almost everywhere on E. And we also know measure is greater than or equal to 0. So that implies that the measure of g sub k equals 0. And now we have a very cool result, which tells us that the measure of g of k is 0, therefore this limit is 0. And finally, since a sub k is a subset of g sub k, right? We have that taking the measure, this measure will also be less than or equal to g sub k, measure of g sub k. And then finally, taking the limit of both sides, we can see that limit as k goes to infinity of measure of a sub k equals 0, which is what we wanted to show. And we're done.